welcome to this lecture on searching array. Let me give you some intuition about this problem, and after that we will return back to the lecture slides. So for this search we will be given two information. First we will have an array like my list, and then we should also have key, and key is something which we will be looking for. So key could be any value, and the program should tell us whether this key is present in the array or not. And if the key is present, then we should be able to find out the location of key in the array. Okay, so for this problem we have two possibilities. Let me write possibilities here, possibility 1 and possibility 2. So possibility 1 is success. Okay, so for possibility 1, let's think of key as 51. And the second possibility is a failure. So when can we have a failure? If I say that key is 100, it depends, right? I can look for the values which are either in this array, or whether the elements are not there in the array. So number 51 is present. So you can see that it's not a big array, just 10 elements, so you can have a look at it and you will figure it out that 51 is present. So that is a success. Whereas if you have key as 100, then 100 is not present in this array. So we need to distinguish these two cases. So our program that we have to write will have to handle these two cases. First case, which is of success, and the second case, which is of failure. So in case of success, we should return the location. So the search process has to return the location of the key. So location of the key in the successful case, like here for 51, would be 9. Okay, so what is 9? 9 is the index. 9 is the index of 51 in our array, input array. Whereas if you have a failure, then also you should return an index. But in that case, the index should give us this idea that, our search was a failure. Okay, so what do we do in that case? For that case, we return index as is equal to -1. Okay, so this is something we follow. Index returned as -1 means that we could not find the element in our array. And if the element was present in our array, then we will be able to find the location of that element, and that's what we should return in our program. Okay, good. So now let's look at two approaches which we follow for searching an element in an array. The first approach is called linear search. So let me use the key as 51. Key is equal to 51, and we will search for 51 in this array. Okay, so what is the approach here? So the approach should be, let's search for 51 in this array till we find it, and it has to be systematic. So what do we do in linear search? We start looking for this element from the first index, which is index 0. So you compare 51 with the element which is present in index 0, and if that was successful, we will return that index. So if 51 was here, I will return 0 and my search should stop. Whereas if your search fails, like we have it right here, then we need to continue our search. So how should we continue? Then I will compare 51 with the next element at index 1. Here again we failed because 51 is not present even at index 1. So we should not stop, we should continue doing it. We will continue doing it till we find that element. Okay, so here we will fail in all these comparisons, when you compare key with the element and index 2, we won't succeed. So that means we should continue to search for key. And only at the index number 9 we will be successful. So you should return 9. What is 9? 9 is the index, or it's the index of 51. So that's what we should return for successful comparison. Now you might wonder, like, why do we call it linear? It's called linear because that's how we are searching for it. Okay, in a linear order, one by one, this is a linear thing, starting with the index 0, 1, 2, 3, 4, continue till you find it. Okay, so if you were searching for key as 89, then what will happen? You will start, if your key was 89, then you will start from 0. 89 is not present here, not present here, not present here. You go on searching till you find 89. So 89 is present at index 5, so 5 is something you will return, and you will not search for 89 anymore. You are done. Okay, so again it is linear. Now you will wonder, like, fine, this was the case where we are successful. How about the case where you will fail? So how about the case where key was, so let me put this index is equal to 9. We will find it out. But if you are looking for 100, so what will happen in this case? Well, you will start searching in the same manner. You will compare 100 with the first element, you will fail. Do with the second element, third element, go on doing the comparison, and even after comparison with 9 you will not find it. Okay, so you need to distinguish this case. You need to distinguish the case where you fail to find it, and that case you'll have to return index or location as -1. Alright, so I'm giving you some idea about the concept behind it, like what the problem is. For linear search, we will search for element one by one. It's not difficult to write. We will do the demo, and I have this code in lecture slide also, so we will understand what we are doing, and ultimately we will implement. Okay, so the important thing is this distinction, whether the search was successful or not. Search will be successful if you are returning an index which is non-negative. Even if you return 0, that means it was your first element, and if it is -1, then that means you failed to find that element. Good. Now let's move on to the next interesting case, which is binary search. So for this case also, let me start with a value of key. I'll take key as 51 here also. I'm looking for the same element, 51. Now for binary search we have a condition. We cannot perform binary search on any array. So the requirement for the binary search is that your array should be sorted. Okay, so look at this array. I have sorted array. My first element is -20, which is the smallest. Then you have 11, 12, 15. So it is sorted in ascending order. So that's a requirement for binary search. How about this case? I cannot do binary search here. Why? Because these elements are not sorted. Okay, so keep that in mind. You can only do binary search when you have your elements sorted. Now, because if you have elements sorted, then only you can exploit this sorting behavior and can do binary search. And binary search we are implementing here, but let me tell you, you might have done binary search in your day-to-day life. We do it very often. You might wonder, where did you do it? Probably when you were in elementary school or in high school, and you were looking for the meaning of say an English term or English language word in the physical printed dictionary. So I'll assume that you did not start comparing that word from the first word that you had in the dictionary. Probably you looked for that word in the middle of the dictionary, and then you figured out that probably this word is in my beginning half or the later half. So what we do when we search for a word in dictionary is we do binary search. Okay, so let me discuss binary search from this example point of view. So what do we do in binary search? This key that you have is not compared with every element. Okay, I will not start comparing 51 with minus 20, then 11, and then 12. No, no, no. Okay, I won't do it that way. So what I should do here, you will always compare 51 or the key with the middle element. Okay, and what's the middle element here? So we have this notion of mid. And what is the middle element? Middle element we find out by doing this computation, which is we will take the index, the lowest index of the array, which is 0, the highest index of the array, which is 9, and we take the average of that. So this is integer division, so it will return 4. Alright, so 51 would be compared with the middle element, and we find the middle element as the element which is present as index 4. So the first comparison that you will do of 51 would be to the middle element, which is at the index 4. Okay, and how did we get that? You have to start with the lowest index, we will call this low, and the highest index, which I'll call as high. Low and high. Okay, you will find these terms like low and high in our implementation also. So you found the index of the middle element. You'll do the comparison of 51 with the element which is present in the middle, which is 16. So right here you need to apply some logic. So the logic says that if your key is greater than the middle element and your array is already sorted, then there's no point searching for 51 in the lower half. Okay, it is sorted. It is sorted, and we also found that this key is greater than the middle element, 16. So because of the sorting thing, and we know that this key is greater than the middle element, then that means I should search for this element in the right half. Okay, because anyway it cannot be here. 51 is greater than the middle element. So in the next stage I will only consider searching for 51, which is my key, on the right half. Alright, great. So then in the next iteration what I will be doing, I will have to update my search. So how do I update my search? Well, now I will focus on the right hand side of the array. So I will mark this as my low. Alright, so my low is no more 0 because I am ignoring these elements. The array is sorted and I am looking for 51. 51 is greater than the middle element, so I can't find 51 on the left half of an array. So I should look for 51 in my right subarray, which is starting at index 5 until the highest index. Okay, so which element should I find for comparison in the next stage? Let me put this as first iteration. In the second iteration, again I will compute mid. What is mid now? My low has become 5 and my high is still 9. So you'll say 5 plus 9 by 2, which is 7. Okay, so 5 plus 9, which is 14, divided by 2 is 7. It is an integer division. So in the next case you should compare with the element which is present at 7. You will compare 51 with the element which is present at index 7, and that is 40. And what did you find? You found that key, which is 51, is still greater than 40. Alright, so again in this subarray you need to ignore these two elements, and in the next stage you should confine your search to this subarray, and this subarray has only two elements at index 8 and 9. Okay, so what do we do in the third iteration? In the third iteration, we'll compute mid again. What is mid? Now this is my low. This is my new low, lower index, and high is again the same, which is 9. So mid here would be 8 plus 9 by 2, which is 8. It will be 8.5, but this is integer division. And what do you do now? You'll compare 51 with the element which is present at index 8, and that is in fact the element 51 itself. Okay, so this will result in success. You might be wondering, like, why are we doing it? Definitely this is much complicated than what we had in the case of linear search, but this is more efficient. Binary search is more efficient. Okay, so what I'll do, probably we need more examples to understand this concept, and hopefully we have sufficient example in our lecture slides. I think we have 2 examples. So if you got this concept, great. Otherwise, I believe the lecture slides will help you even better, and then we'll do the implementation. And with the implementation, you will understand that this approach is more efficient. And in my demo also, I will modify my code, and by modifying the code, you will get an idea that the binary search is more efficient than linear search. You don't need so many comparisons, right? So let me try that. So how many comparisons you had to do to search for key 51? So you first compared with the middle element, that is 1 comparison. You compared with 16 and you figured out that 51 is present on the right subarray. So that's 1 comparison. Then using the index 5 and 9, you computed the middle element again, which was 40. That was the second comparison. Okay, so this second comparison again gave you an idea that 51 is on the right hand side of 40, and that was the third comparison. So here in the binary search you had only 3 comparisons. In 3 comparisons you were able to locate the key 51. Whereas if I take you back to this case, then you can find out how many comparisons you had to do. You compared with the first one, that's 1 comparison. You compared with second, third, fourth, fifth, sixth, seventh, 8. So here you had how many comparisons? You had 10 comparisons, right? So here for linear search you had to do 10 comparisons to find out the index of 51. Whereas in this case, when you have the binary search, you had to do just 3 comparisons. Okay, so you might be wondering, like, what will happen if you have the first element? You are searching for first element, which is minus 20 in this case, and if you're searching for 12, yeah, definitely here linear search is more efficient when you're searching for first element. But usually when we compare algorithms, like which algorithm is better, we always consider the worst case performance. So in case of worst case performance, binary search is always better than linear search. Okay, probably you will study about linear search and binary search in your CSE114 when you study data structures. Okay, so let me take you to my lecture slides and then we will do implementation. Okay, so searching arrays. So again the same thing as I told you with my intuitions. For this problem you will be given an array. We are calling it list in this case. So list is something like this. We don't have elements here, but just put some values in. Could be 2, 5, 20. It is up to you what values you want to put. And there is a key that we are looking for. Okay, so you need to write a program which we will call that as linear search. And for this program, you will be given an array and a key, and you will search for that key in the array, and on the basis of the search result you will return a value. Okay, so that's the return type. And how should you declare this method? So you'll have public static int is the return type. Why is the return type int? Because we will be returning an index, and the index would be a positive value when we succeed in finding the location of key in the array, and it will be a negative value, which is -1, if you don't find that. Okay, so what is searching? Searching is the process of looking for a specific element in an array, and that specific element we'll call as key. Okay, so what is the linear search? Again, we have interesting example uh, to highlight how linear search works. Now this list is an array with 1, 2, 3, 4, 5, 6, 7, 8 elements. Now what do you do? Start, our key is 3, compare 3 with the first element, which is 6. We did not succeed, so we should continue searching. We will compare 3 with the next element at index 1, which is 4. We could not succeed. We should go on. Then you compare 3 with the element which was present at index 2. We did not succeed. Keep doing it. We compared 3 with 9, which was at index 0, 1, 2, 3. We failed again. Okay, so keep doing it. Now we will compare 3 with the next element, which is 7. Problem here again. And then we will compare 3 with the next element, which is at index 0, 1, 2, 3, 4, and 5. So at the index number 5, we were able to find the match. Okay, so our algorithm should return this value. Our program that we have to write will return this value. It should return the index of this key if that key is present in the array. And here the index is 5. 0, 1, 2, 3, 4, and 5. Okay, so this linear search program, if you write, it should be able to return the index 5. Good. So now about the implementation, which I believe is simple. Okay, it's simple. So let's see, how do we implement this linear search? Binary search is slightly complicated, but let's not worry about binary search right now. Let's look into the linear search. So here you have to keep the same header or the signature of your method. It is public static, int is the return type. We are calling it linear search, and here the formal arguments are the array. Here we are using integer array. We're calling that list, and it's an integer array, so you should keep that like int and square brackets list, and then you need a key also, because you're searching for something, and I should tell you what is the key. Okay, I should give this value as well. So now how do we write this program? So for this program we will use a loop. Okay, because what we are doing, we are comparing the key with every element. Okay, so what I should do, rather than reading this program step by step, let me write the demo program, and I believe that will be more helpful. So here I have this skeleton program written. I'm calling that a class as search array. I should call it search array. Okay, so what should I do here? Let me write public static int linear search. Alright, and here I should pass on a couple of arguments. Let me call that list, and the second is key. List would be an array in which I will look for key, and its return type is int. It's public static. Linear search is the name of my method. So what I'll do here, let me declare a variable log is equal to -1, return log. Okay, so what I'm doing, it is up to you how you implement, and this implementation is slightly different than the implementation which we have in the lecture slides, but both are correct. Okay, so you might wonder, what is your approach? Why are you initializing log as -1, and what is this log? So log is the location or the index in which the key that I'm searching for might be present. Okay, so my approach is a little pessimistic. So what I'm saying is, let me assume that this element is not present, the key is not present in my list at all. And if that is the case, then my index should be -1, and that's what I will return. Okay, so this is pessimistic approach, but I like this because it is very convenient. So you will understand very soon what I'm doing. Good. So what should I do now? Right, so it's a very simple case of a loop. So let me do int I is equal to 0, I is less than list dot length. Okay, I plus plus. So as probably you got it, like, it's a linear search where I have to compare key with every element. This key I need to compare with every element. So assume that I am calling this linear search on the array which I have defined in the line number 3. So what should we do? We need to compare this key with every element one by one till I succeed. Okay, so what should I do? I need to write a conditional inside my for loop. So how should the conditional look like? I should write if this key that you're searching for is equal to list I. Okay, if that is the case, then we are good, we found that. What you should do, log is equal to I. What does that mean? When you started with I, you would succeed somewhere. Okay, and wherever you succeed, how will you succeed? You will succeed when this key that you're searching for is equal to the element. Okay, that means when the key is present. So in that case, what you should do, you should return that location. So let's be specific. If key is 89, alright, if I'm calling this linear search with key value as 89, so what you should do, you will have to compare key which is 89 with every element. First element you will not succeed. Go on searching, right? So this for loop will take care of that. It will take care of incrementing I one by one. Then you'll compare 89 with -20. That will not be a success. Go on doing it, and when you hit 89, then yeah, you should stop right there because you found the location of 89, which will be I, and you need to return that. Okay, and this fact that you have to stop should be reflected by having a break. Alright, so why do I have a break? Well, if I found the element, I don't need to search anymore. I was looking for 89, I found 89 at this position. This doesn't make much sense to continue searching for 89 anymore. I should stop. Alright, otherwise, go on searching. If this is not the case, I'll continue searching. Okay, now you might wonder, is my program correct? I believe it is correct. Why? See, the only time where my location is changing is right in this case when the key matches the element. Okay, and if there's no match, then my location variable which is holding -1 would never change. And what is the meaning of location as -1? Meaning of location as -1 is that you failed to find that element. Okay, so let me write the program here to check that. So I should say int position. Okay, so for position I should call this method, I'll say linear search. That's a linear search. My list, and let's look for key. Key is 51. And what I'll do here, let me use an if statement. If pos is less than 0, if you fail to find that, what should you do? You should say that system.out.println key is not present in the list. Done. Okay, else what you should say, that key make that bold in the list at position POS. Let's run this program. So what should I say? Java C search array Java. Alright, so there is an error on the line number 16. Let's see what is that error. I is equal to 0, I is less than list dot length, I plus plus. Okay, so see, this is not a method. Alright, so that's a common mistake that we make. Then I'll say Java search array. Okay, so 51 is present in the list at position number 9. Let me double check. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's perfect. Now what I should do, let me change this position to 100. And we are sure that 100 is not present. Okay. Let me compile this program. Hundred is not present in the list. Good, it's done. So we implemented linear search, right? Think about it, implement it yourself, and you'd like it, right? It's very simple. Just what? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 lines of code. Alright, so let me take you back to my lectures. Alright, so similar approach we are applying in the lecture slide. Also, you have an array as the first argument, then the second argument is key, which you're searching for, and we will use for loop. You can also do this program with the while loop, which is same. And what we are doing, if key is equal to list I, that means in this iteration, if you are successful in finding the position, then please return it. So your program will stop right here and that value will be returned back. If not, then you can return -1. Okay, so this will work too. So try both the methods, this one and the one that I did, and pick the one that you like. Okay, so now when you have declared your linear search in this way, what are we doing? You have list created with 1, 2, 3, 4, 5, 6, 7, 8 elements. Okay, and now you're using linear search to search. You're calling this method to search for 3. Okay, and 3 is present at 0, 1, 2, 3, 4, 5th index. So the return, if you print I, you should be able to print 5. In case of -4, see, -4 is not present in your list, so you should return -1. And similarly, when you're searching for 4, you should get 1. Why? Because its location is at 0, 1, index number 1. Okay, good. Now let's do this binary search, which is more interesting case. So if the array is already ordered, then it is cheaper to find an element. Cheaper means it is more efficient. It will take less number of comparisons. So that's what I was trying to convey in my example that I started with. Okay, so you will have to do less comparisons when your data is already sorted, because you can apply binary search. Otherwise, binary search is not meaningful. So assume that your array is in ascending order like this: 1, 2, 3, 4, 6, 7, 8, and 9. Alright, so binary search, what it does is it will always start the comparisons with the middle element. Okay, so if the key that you're searching for is 8, so you'll find the middle element and you'll compare 8 with the middle element. And how do you find out the middle element? You'll have to use the index of the first element and the index of the last element and add those two, and divide by 2. Okay, so what will you do once you have the middle element? Now you need to decide. Okay, so what do you decide? Let's see these points, because I already showed you some calculation, but let's be systematic and try to understand what are the different steps involved when you're comparing the key with the middle element. If the key is less than the middle element, you only need to search for the key in the first half of an array, of the array. If the key is equal to the middle element, well, that's the success. You don't need to do anything. The search ends there with a match. Okay, now that was the second situation, the pleasant situation where you found the element. If the key is greater than the middle element, what do you need to do? Then you only need to search for the key in the second half of the array. Okay, and keep doing it till you succeed. All right, great. So now let's look at this example to understand this pattern. So we are searching for 8, which is key, and our list has these elements, 1, 2, 3, 4, 6, 7, 8, and 9. So here, let me try this thing. I will use pen right here, because wait a second. Okay, so why I should use pen? Because that will help us in our understanding. And I will write indices 0, 1, 2, 3, 4, 5, 6, and 7. Alright, so now I know the index of every element that I have in the list. So we, as I said, that in the binary search we always start with the middle element. So 8 is the key which I need to find. I should compare 8 with the middle element. Now how do I find the middle element? In the first stage, the middle element that I have is equal to, the lowest index is 0, the highest index is 7, 0 plus 7 by 2, which is 3. Okay, so it's the integer division. So we will do the comparison with the element present at index 3, which is 4. Now compare 8 with 4. While comparing 8 with 4, you found out that the key is bigger than the middle element. Okay, so since the array is sorted, it's meaningless. We will not compare 8 with these elements, right? What we should do, we should search for 8 in the right subarray, and the right subarray has these 4 elements, which are 6, 7, 8, and 9. Alright, so we are done with the first iteration. So what are we doing in our second iteration? In the second iteration, we will confine our search to the right subarray. Okay, to the right subarray. So we will have to update our low. Okay, so this low and high is something you will see when I implement. But the point is, we need to find out the middle element in this right subarray. 4 was the middle element in whole of the array, and we compared 8 with 4. But now after this comparison we realize that 8 is in the right subarray. Okay, we will not consider left subarray anymore. So now we will think that this is the only array in which we have to search, and for this subarray again we have to find out the middle element, middle of this subarray. So how do we find out the middle in this case? Mid is equal to, my low is now 4, low is 4, low is not 0, okay, because I'm only considering this subarray. Okay, so my low is the index 4 and my high is index 7, and you do 4 plus 7 by 2, which is 5. It's an integer division, right? Okay, yeah. So that is the reason in your next iteration you're comparing 8 with the element which is present at index 5, and that element is 7. And the result is same as we had in the previous case. The result is that the key that you're comparing, which is 8, is greater than 7. So again you have to ignore these two things, and you'll have to confine your search to this subarray, and this subarray has only two elements, which are 8 and 9. Okay, so what are we doing in the third iteration? In the third iteration again you'll have to find out the middle element of these two. We always compare with the middle element of this array when we are doing binary search. So how do we compare mid in this case? In this case my mid is index 6 plus index 7 by 2, which is 6. It is an integer division, right? And luckily for us, this comparison results in success. Alright, so we succeed. So that, see, understanding binary search would be slightly complicated than linear search, but its implementation is more complicated. But it has to come in that way. First you need to understand the concept behind binary search, and then you should try to implement it. Implementation is slightly interesting and yeah, slightly complicated. Okay, so we do have implementation, but again the way I did it for linear search, let's not look at the implementation right now. Rather, let's implement it ourselves. Okay, so I'll take you back to this program, and since we have already seen linear search, I will write the other search, which is public static int, but I will call it binary search. Okay, so in binary search also you will have the same kind of arguments. Alright, and here let me see, I can follow the same approach, the pessimist approach, which is log is equal to -1. Alright, and I'll say return log. Okay, great. Now I need to think about the logic for binary search. Let me push this down a little bit so that you are focusing on this code. Now here we need this concept of mid, low and high. What are low, high and mid? These are the three indices that we need for binary search. Low is the lowest index of the array, so initially the lowest index of list, which is 0, and high will have the highest index possible for this list. Okay, so let me initialize that right here. Low is equal to 0 and high is equal to list dot length. No, it should be -1. Alright, yeah, because you know that index is 1 less than the length. Now what do we do? In the binary search, I told you that we always compare with the with the middle element of an array. So let's compute the mid. And what is mid? Mid is an index actually. Low is an index, high is an index. Low has the lowest index, high has the highest index and mid has the index of the middle element in your list. So it should be low plus high divided by 2. So here I should be careful because of the precedence thing. Put these in parentheses and then I'll divide by 2. Okay, good. And what do we do here? We will have to compare, right? So let me write these basic methods. What I will do, if key is equal to what? List mid. That is, the happy situation. What do we do? We found that, right? So location should be equal to mid, right? Because you found that element at that index, the middle index. So luckily, if we could find key as the middle element, then we don't need to do anything, right? We'll say lock is equal to mid, done. But at the same time, you should break as well. Alright, why break? Because you found the element, there's no point continuing any further. Alright, great. As now we need to think about other situations. What can happen if key is less than list mid? Alright, so what does that mean? Well, that means that the element that you're looking for is less than the middle element in the array, and the array is sorted. So what you should be doing in that case, you should confine your search in the lower half of the subarray. And how do we do that? How do we enforce the lower half? For that, you will have to update the index of high, okay, because it's no more the right hand side. It's kind of on the lower side. So what do? We will update high. We will say high is equal to mid minus 1. Okay, great. Okay, so if key was less than the middle element, then you will confine your search to the lower half of this, what do you call it, subarray. Otherwise, if it is the other way around, then that means your element or the key is greater than the middle element. So in that case, you will have to update low. You will say low is equal to mid plus 1. So these things are little interesting, and you need to think about it, right? So if these are the kind of things you'll be doing in probably in your CSE214, but we are doing problems of this level in CSE114 also. Okay, so don't think that it is just CSE214 stuff, so I should not be concerned about it. But yes, it has the complexity of that level. Okay, so fine. So what did we do here? Well, we found the middle element. What is the mid here? Is the index of the middle element in my list. How do we do that? The index, the lowest index plus the highest index divided by 2. It's an integer division. You'll get an integer. Then you compare the key which you're searching for with the middle element. If that was a success, let's update lock to mid and let's return back. We are done. Okay, return back means let's come out of this loop. I have to write a loop. Okay, I did not write loop for the reason that I want to go step by step. I don't want to make it too complicated in the beginning. Okay, I'm just writing one step, and if you understand this step, then very easily I can put a loop on top of that. Great. So if it was a successful case, then you found the element in mid, put that value in lock, because lock is what we are returning on the line number 13. If we were not so lucky, then we have to think like, where is this key falling? Is this key falling in the left subarray or the right subarray? If it is falling in the left subarray, then we'll have to squeeze our original array search to the left subarray search. And how is that happening? That is happening by updating this high index, which was initially the highest index, to mid minus 1. Okay, because we know that mid is anyway greater than the key. So high would be mid minus 1. Otherwise, if the case is that key is more than the middle element, then our low should be updated. Now our low would be mid plus 1. That way you will be searching for the right subarray. Okay, cool. I hope that this is making sense. Now what I should be doing, let me put all this thing that I have done here, Control X, right here. Okay, let me indent it properly. Alright, great. So what should I write here? Well, I need a condition. What is the condition? Condition is while low is less than or equal to high. Okay, so this is the condition. How long should I continue doing it? I should continue doing it till my low and high index coincide. And when will they coincide? They will coincide only when I have an array of just one element. Okay, so this is interesting. I hope that the examples that I have will help you understand this condition, like low has to be less than or equal to high. You will continue performing these statements till your low is less than or equal to high. Alright, so that's the condition. So now what I will do, assuming that what I did is correct, let me copy this here, but I will block this code because we have seen that it works. In place of linear search, I should call binary search. Let me copy this. Okay, right. So the rest is same. Binary search has the same syntax as the linear search. Okay, so linear search was this way, binary search is this way. Okay, my list and key. But now see, I cannot use my list for binary search. Reason being, my list is not sorted. So the first condition for binary search is that your array should be sorted, and that was the reason I created the second array, my list 2. Okay, so let me use my list 2 for this task, and my key is 100. So let's see. I should say good. Then I'll run. Okay, so 100 is not present. Is 100 present here? No, 100 is not present here. Okay, so now let me use 16. Yes, 51. Okay, let's do 51 because 51 is what we had done. And after that 51, I will try the other keys as well. So 51 is present at index number 8. So let's say 0, 1, 2, 3, 4, 5, 6, 7, and 8. That's correct. Let's try that with 16. So k should be changed to 16. Still as. Sixteen is present at position number 4, 0, 1, 2, 3, and 4. Okay, good. So it seems like it is working, and it has to work, right? Because I don't do anything fancy. I'm just following the instructions or the steps of binary search. Okay, good. So let me take you back to the lecture slides. This is something we had done. Okay, so now we have another version of binary search. This binary search might be different than what I have done, but conceptually these two are same. It is up to you which one do you like. So let me try to explain this implementation of binary search. Your low index is 0. Good. Your high index is list.length minus 1, the way I did. Now what are we doing here? While high is greater than or equal to low, and I had written it the other way around, but these two means the same thing. You will have to find the mid index, which is low plus high divided by 2. If key is less than the element which is in the index mid, then you'll have to update your subarray to the left subarray, and you will say high is equal to mid minus 1. Otherwise, if you found the element at the index mid, you are done. Okay, so you should return mid. Alright, otherwise just update low to mid plus 1. So when you update low to mid plus 1, then that means you are considering the right subarray for the binary search in the next iteration of the while loop. Okay, again, please implement it. First, before implementation, you need to understand the concept behind it. Binary search will only work for sorted array. Only when your array is sorted in the ascending order, you can apply binary search. Even for descending order, you can apply, but then the logic will be different, slightly different, but it is possible. Okay, so first work it out on a piece of paper, just to make sure that you got the concept, and then implement. Now here we have some example which will help you understand how binary search will work. Now this is your array, and in this array, good thing is that we have even the indices marked on top of the array. So here we have 13 elements because high is 12, so the length should be 13. We are searching for 11. Our key is 11. Okay, so what is happening? The middle element is the index 6, is at index 6, which is 50. When you compare key with 50, 11 is less than 50. That means we should not consider the right subarray anymore, not even the middle one. And now we will search for 11 in the lower subarray. And here for the lower subarray, again you should find the middle element. The middle element right here is 7. 11 is greater than 7. So what will happen? Of this left subarray, again we have a right subarray. Okay, from this left subarray now, because 7 is less than key, we'll have to confine our search to the right subarray. Okay, so after second iteration, we are left with these three elements only, and these low, mid, and high, these are the variables which have to change, and from low, mid, and high only we are able to confine our search to a part of the initial array. Okay, so right now we have only these three elements with low as 3, high as 5, and when you use 3 and 5 as low and high, your mid will be 4. When you compare key with the fourth element, which is mid, you found it, and that's the success. Great. Okay, so now let's look at the element number 54. The key is different now. When you compare 54 with 50, which is your middle element, then you figured out that key is greater than 50. So you need to search for 54 in the right subarray, and your low has to update, right? So now the low should be 7. Then you'll find the middle element using low is equal to 7 and high is equal to 12. Mid is 9, the index is 9. You compare 66 with key. Key is less than 66. So now you're left with low as 7, high as 8. When you use low as 7 and high is 8 and you find the mid, then the mid comes out to be 7. Okay, you compare 54 with 59 and that did not work. Okay, so what will happen, then you will update high, and high will in fact be less than low. So when high is less than low, that means you cannot search anymore, right? So what will happen in this case? In that case, you'll have to return -1, which will give you an idea that the element was not present in your array. Okay, so that was about the binary search and linear search. I will make another video. I don't want to add more complications. I don't want to make it more complicated, so I'll stop right here. I will post another very short video in future, which will have the modification of this implementation, and in that implementation I will have the comparison information also, and by that you will be able to understand how binary search is more efficient than the linear search. Okay, yeah, thank you so much.